There's two homework problems that I'd like to look at, just to kind of help you get started. Just to make sure you know what's going on with some of the inverses. So this is number 56. It says here's a function, find its inverse, and we know that the inverse function of sine is arcsine, or inverse sine function. So hopefully that part makes sense. And I'm going to treat it sort of like what we did last semester, where I'm going to replace the x and the y, and really just try to isolate this y variable. So the first thing I might do is divide this by 3. So x thirds is equal to sine of 2y. And then the thing that undoes sine is arc sine. So I'm going to arc sine both sides. So arc sine of this side, x thirds, is equal to 2y. And then we can divide by 2 or multiply by 1/2. So 1/2 arc sine of x over 3 is equal to y, or in this case, the inverse of x. Okay, now, so hopefully that part is easy, and all of the trig functions, you would isolate them by doing, like, kind of switching the x and the y, and then, applying the inverse trig function. But what I also want to look at is, well, what's the domain and range of this particular function? And remember that when you have arc sine, you're looking for, like, you're putting in a ratio. So you're putting in a ratio into that, and out comes an angle. So you're putting the ratio into the function, and you're looking for an angle that has that ratio, right? And just as an aside, right? So if I said, okay, what's the arc sine of 1/2? So again, 1/2 would be the input, right? That's the domain of the function. The output would be what angle does that give you. So the angle that has a sine ratio of 1/2 is 30 degrees, or pi 6. So the range of these functions, in terms of finding inverses, like the range are going to be angles. So if you think about all of our trig functions, like when you're drawing them, they're either in quadrants 1 and 4, or they're in quadrants 1 and 2. And when they're in quadrants 1 and 4, remember the range of values is from negative pi over 2 to positive pi over 2. So when I'm looking for the range of an inverse, it's either, like initially it's going to either be from negative pi over 2 to positive pi over 2. And remember, that's if you're like arc sine, because that would have been negative down here, arc tangent, and arc cosecant. Like, those would be your initial ranges between negative pi over 2 and positive pi over 2. And if you were, the other three, right? So if you were arc cosine, or arc secant, or arc cotangent, your initial range would have been between 0 and pi. So like, that's always our place we're going to start. What kind of function do we have? And in this case, it's arc sine. So our initial range is going to be between negative pi over 2 to positive pi over 2. The only thing that could change that potentially is if you are multiplying by something in front as a coefficient. So in this case, my range of values will always be multiplied by that factor of 1/2 in this particular example, right? So it's almost like you're saying, I'm going to take 1/2 times the interval negative pi over 2 to positive pi over 2 to get my range of values. Like, if there was like a 7 in front of this, then I'd multiply the range by 7, right? So then this new range of values becomes negative pi over 4 to positive pi over 4. So that's the range of our function. And then, again, thinking about the domain of all, like, at least for arc sine and arc cosine, when you're putting ratios, right, when you're trying to draw that triangle, the only kind of ratios that you can put in here that make sense into this are ratios that are 1 or less, right? That's the way the sine ratio works and the cosine ratio works, if I had that. So that means I want to make sure that this thing that's within my arc sine function, I want to make sure that that represents something that would also fit that bound. So I'm going to take, I'm going to take that x thirds. I'm going to take x thirds and make sure I bound it between 1 and negative 1. That way I know that whatever gets in there will fit the sign ratio. Well, I can multiply both, like all pieces of the inequality, by 3. So then this becomes the domain of my function. Now, of the inverse. Now, thinking about like how functions and inverses work, there is a little bit of hindsight here, because if you look at this 3 at the very beginning of our function, that 3 dealt with the amplitude, right? And the amplitude of that function, that amplitude would have been like the highs and the lows, the peaks and the troughs. So the original function of going up to 3, down to -3 like that, because that was our original range of values, up to 3, down to -3, look how that now became the domain of our inverse. Well, right, and so there's some good sense of checking that just to double, to make sure. Sines and cosines for that domain are going to follow the exact same way, because again, your ratios for sine and cosine can really only be between -1 and +1. Okay. The other one is number 57, which numerically comes after 56, but it's on the different side of the page, so it's a different section. But that's okay. So in this one again, it's not hard, but like it looks weird, right? And so maybe we're not really sure what to do. So it says find cosine of inverse tangent of u. Write your expression as u. So I think the key here is to realize that u could be written as u over 1, right? A u to 1 ratio. So we will draw, again, assuming u is positive, because otherwise we would have made it a negative u. You could draw a ratio of u to 1 for tangent, and then this is some angle that we don't know, but we could certainly fill in the missing side using the Pythagorean theorem. This would be the square root of 1 squared, which is 1 plus u squared. So then when it says now find the cosine of that, well, cosine is adjacent over hypotenuse. So then the cosine of your angle would be 1 over the square root of 1 plus u squared. I'm okay leaving it like that. You can certainly multiply by the conjugate if you'd like. So you get the square root of 1 plus u squared over 1 plus u squared. So those I think actually are easier once you know, just treat the u as a ratio and use the Pythagorean theorem. So hopefully that helps with some of the domain range functions, as well as the second set of questions there.